why does our cylinder not match the cylinder it thinks it's seeked to? Let me show you, if you're just joining us. We got some stuff going the other day. So we had this going, floppy power, let it initialize, Nintendo power, Nintendo power, and we turn it on, and what it's going to do, it's going to reset the drive, seek to track 0, do a bunch of other setup stuff, and then attempt to read cylinder 0, head 0, sector 1 is what it's going to try and do. But you'll see, well, it will complete it, but we don't read. So this is our monitor prompt, and we dumped the result values into memory, and they are not, we only get 7 of them because it only sends the job done status bytes that say the cylinder on the disk does not match the cylinder that the controller thinks it's seeked to, which is spooky. So basically we have to figure out why the heck that is. Maybe we encoded the command wrong. Maybe the setup on our disk is wrong. Maybe it's reading sectors wrong, like our data rate. It doesn't match what is actually supposed to be on a 1.44 meg floppy. I don't know. Another debugging sesh. And as always, we open today's episode with Wereworm saying, evening. So anyway, as I said, for those just tuning in, because please skip over episodes to see what's going on, but yeah, so it did it. The stuff is in memory, and it is decreasingly at 207. I need to probably put a 0 in front of that. Maybe I don't. 0207. Doot doot. 0206. Doot doot doot. 0205. Doot doot doot. 0204. Doot doot doot. 0203. Doot doot doot. That 0204 is probably bad, but anyway. As in, I put in the monitor commands wrong. Anyway, 0202, doot doot doot. 0201, doot doot doot. And that's our stuff. And basically, those first 3 bytes are saying there was a problem, or the command was canceled, there was a problem of this nature, and then the third one is finally saying the nature is cylinder doesn't match where I think I am on the disk. If you don't know about floppies, and I'm not a super floppy expert, but all of the information about where the sector is physically on the disk is actually present in the data on the disk. There's kind of like a header that precedes every sector on the disk that says, I am this sector, I am on this cylinder, probably head information as well. So basically what it's telling us is that for some reason that information doesn't match what the drive thinks it's seeked to. It's seeked to track 0. So why the cylinder would say it's not cylinder 0, I don't know. But that's what we're going to figure out tonight. And if my videos historically, keep to a historical trend, it's going to be that that's not really quite the issue at all. But we'll start diving into that and seeing what it is. So let us review. And I had to reset my computer again, so bringing it all back up. But let's review the code. Yet again, look at the setup. Yet again, look at the manual. Yet again, see if there's some dumb, obvious thing about us seeking to the wrong place or something. Or setting the cylinder up in the command wrong, or something like that. I'm curious if it might be, I was going to say the wrong head, like it starts on head 1 instead of head 0 for some reason, but that it would be the same cylinder. So, technically a different track, same cylinder. Anyway, we are doing so we are seeking to track 0, ostensibly, and we are subsequently, setting up sector stuff. So we say cylinder 0. It would be very nice if it told us what cylinder that the floppy says it is, but it doesn't, which is kind of annoying. Does the read happen right after the return to track 0? Should. It's not even a return to track 0. There's a whole explicit seek to track 0 here. So I might want to double check this. But I mean, the head looks like it's at track 0. Everything looks fine. But of course, that is the issue. So that's probably a place to look. And, theoretically, it does the seek. It waits for an IRQ to be raised to make sure, it actually is done seeking. And sends a sense interrupt command just to make sure, make dang sure that interrupt was accessed or detected and cleared. And then after that, we begin the read sector. So, should be done seeking. Should be. But let's read a couple documentation things. Let's start with... What was I thinking? Yeah, let's look at seek just to see if there's something silly. Something totally ridiculous. OSDev, FDC, let's go. Woe is me. Fun thing is, once we get this working, we're gold. That's like, we're over the biggest hump. Seeking. Motor needs to be on, drive needs to be selected. Those are true. Blah, blah, blah. Maximum cylinder number is blah, blah, blah. Blah, 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 blah. There's really no reason to ever use head 1 when seeking. Okay. So the seek command is 0xf. Where is it? There we go. F. Good. The first parameter byte is the head number, shifted left, ORed with the drive number. We are on drive number 0, head number 0. There we go. Second parameter byte is the requested cylinder number. That's that. Cylinder number is 0, which matches the cylinder number in our this thing. Theoretically. So. A sense interrupt command is required after this command completes to clear it from being busy. That's fine. We are doing that. Sense interrupt. Look at that right after this. Tries to remember what cylinder the drive is on. We'll ignore if it's already on the same thing. That's cool. That's fine. Okay. Let us look at the data sheet. Hi, the moon. It's not often the moon talks directly to you. Mostly because it's not sentient. So that's kind of surprising. Yes, I am looking for bit savers. There we go. There's my old standby link. Good times. All right. Let's look at this dang old. Like, you gotta wonder. You gots to wonder. If there is, setup stuff that I don't have correct. Reading. Apologies. Seeing if there is any obvious... Oh, that's interesting. But still, the cylinder wouldn't be wrong. Anyway. There is, in fact, a head select bit somewhere. Oh. That's the pins on the thing. It's been a long day. So I don't need to look at those. Those are not accessible by me. Oh, there is a head select bit though, but on hardware reset. Let's see. Yeah, this is in PS2 mode, so head select is in fact 0 on reset. And this is a read-only register anyway. You know, what if I just went ahead and read this really quick? Just double check. I mean, the thing just finished a command. It'd be interesting to check. So that's a read from 000, which on our thing is, oh, where did we put it? I think it's 6800 would be the thing. Then we dump that, and it is 16. So what would 16 be? Let me write that out because I am bad at this. 16 would be 0001, and then a 6, which would be 0110. And that means, what does that mean? So direction is 0. I don't know what that means. We'll see. Write protect is high, which means it's not active. Index is high, whatever that is, it is not active. We'll check, maybe it's important. And then head select is 0. It is 0. And the tracks, oh, now that's fascinating. Ish. Track 0 is high. And track 0, so I mean that would explain things. That would explain why it's not at track 0. Or, you know, maybe that it's not at track 0. Let's see. I'm expecting it to have a definition of this, and I'm not seeing it. Hello? Where's the definition for the track 0? I mean, that just reflects the status of the pin that's fed into the thing, right? Yeah? Right? So, oh yeah, the bits marked with a degree sign reflect the state of drive signals on the cable and are independent of the state of the invert pin. Interesting. Anyway, so track 0 is a 1, which means it's not asserted because it's a active low signal. That's freaking interesting. Is the drive not indicating that we're on track 0? Why could that be the case? Like, it looks very physical. Oh. Sorry. I swear to God, I'm getting worse and worse at this. Right here. Track 0. It's this bit. Yeah. Anyway. That is set, meaning we're not at track 0 physically, which is bizarre. I'm curious. Like, I don't feel like I can physically move this any further back, but maybe I'm wrong about that? I just want to see if I can get the track 0 signal to go low just by physically tweaking the thing. Sorry, you always can't see what I'm doing. So I just twisted the thing a little bit further back, twisted the feed screw there, and oh, right, status register is what I was going to do. So that is 68. Doot, 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 doot. Oh, so we are not at track 0. What the hell? That's very interesting. Why, after a specific seek command, is it not at track 0? Huh? Anyway, sorry. Wareroom says, is the seek track 0 the same as the recalibrate command? I would think do a recalibrate and then read the sector as it should be on the 0th track. One would imagine that my seek shouldn't do anything because I'm doing a recalibrate and then I'm doing a seek. So, yeah, I mean, let's just take the seek out of there, right? See what happens. For For shits and giggles, let me actually physically manipulate this again so that it is not... Oh, you know what? I'll just reset the whole thing, because that'll cause it to do the whole floppy initialization doodad that puts it at the innermost track, like so. There. Cool. And whatever. I need to reset this all anyway, and I need to update the code, so you can be off for a second. But yeah, let's burn a new copy of the code that just skips the seek part entirely, because you're right. After I mean, we would want to be able to seek in the future, but after the recalibrate, we should totally be at track 0. So if we're not, then there's something real fishy going on. Okay, code boys. So we want to comment out literally all of this. Actually, I'll just do this the lazy way and do jump, skip, seek, and skip, seek. Because I don't have block comments in here. I might. I don't know if they're supported, but so whatever. We're just gonna physically jump over the goddamn thing. Yeah, that's it. Let's do it. Let's see what happens. And also the weird thing is, I've got implied seek mode enabled, theoretically. So even if it wasn't already at track 0, you'd think it would force itself to go to track 0. Huh? What? I don't know. Is this drive physically screwed up? I don't know. Could be. It's hard to say. Anyway, let's do the classic build that twice. XG Proa. Make sure that check ID bit is unchecked. Now, at least I nail that every time now. And basic bin, and offset the thing, and OK, and program, and ooh, yeah. Wareham says the manual tells you may need a second seek recalibrate if the head is more than 80 tracks in. Interesting. Which is, you know, we've talked about this a bit. That would make sense because, excuse me, physically the drive supports up to 83 tracks. They just don't generally use the last 3. So I wonder if it's seek to track 83 and then it's like at track 3 or some crazy thing. So the recalibrate then thinks it's at. You'd still think like it has a track 0 sensor, but whatever. Unless it just, no, I don't know why would that be, but I mean I trust you that that's what it's saying. That's just the reasoning behind that sounds a little bit silly. Yeah, actually, if you're just telling me that, then screw this, because this will still not work, because we'll still be recalibrated to, like, track 3 or whatever it is. So actually, let's just do two recalibrates, huh? Why the hell not? So where's my recalibrate? Here we go, here we go, here we go, go. And let's just do a good old-fashioned load X 2. Blue buddy blue. And I don't have to worry about it because I already made sure that these commands don't mess with my registers. Smart guy. Right? I did do that, right? Screw it. I just want to be dang sure. I'm just going to physically copy it. Don't tell anyone. Whatever you do, don't tell anyone. Just remove and test remove. There we go. I'm feeling good about this because that would explain everything that we just saw. Okay, now that's that. It built. let's do this again. Load it from the thing. I'm so sad that like the record streaming thing didn't work. Now I've got Queens of the Stone Age stuck in my head, and there's nothing I can do about it. I mean, I could listen to it, but what's the point if I'm not if we're not having a party, you know? Okay, that's programmed, right? I did that. Where said maybe check the flag for track 0 after they recalibrate. That's probably the proper way to do it. Yeah, I'm sure it probably tells you somewhere that I haven't looked at yet because I am not thoroughly reading the documentation. That you should like probably just keep checking that flag and recalibrating until the track 0 sensor is actually indicating we're at track 0. Anyway, let's see about this. Okie doke. So first thing I'm going to do, very first, I'm not even going to check the data. Let us 6800 set read. Now it's at track 0. Now I'm excited. Okay. 0207 all ready? I feel like this might be it. It's a big fat 00. Cool. So it's gotten worse somehow. Interesting. Let's just keep looking at what's in memory. That's a little bizarre. 0206 boop boop boop. 0205 boop boop boop. Lots of zeros. 0204 doot doot doot. 0203 doot doot doot. 02 oh shit. 0202 doot. 0201 doot doot doot. What the actual shit? It's different now, but it's super duper garbage. I was excited, and now I'm not as excited anymore. Huh. Okay, well I wait for my brain to have thoughts. The interesting thing is that it does still end in an 02, which is the status byte stuff. But if everything is 0... Anyhow. Bro10 Studios, Twitch TV VOD says, thought about, after figuring this out, to try and build a PCB that has a multi-card selector of every game you own. I think that's a little out of scope. And if I was gonna do that, I would just buy a multi-card. But you're having ideas, and I like that. Hello, Santiago. You've met us in the stage of the classic stage of a great high and then a great low. So Wereworm pointed out, well, I noticed, and then Wereworm pointed out why that might be, that when we were reading the disc, we were actually not at track 0 physically. Classic track 0. Yes, indeed. So, of course, things weren't working because we weren't at track 0. What you gonna do? Yes, because apparently recalibrate commands only move your head back 80 spots, and the innermost position when the floppy resets is potentially like 83. So we overcame that. You can actually see at the top of this screen that 06 is the status register that includes the track 0 sensor, and the track 0 sensor is asserted saying it is at track 0, which it wasn't before. And now we are getting different values when we're reading result bytes from this thing. And they're still, well, now they're, like I said, they're different, but they're different wrong. They don't match the floppy. Is there anything weird like sector 0 is on head 1 or something stupid? Is that a thing? Broten Studio says, make your own NES game that pages new ROM data from floppy exceeding max game sizes typical of the NES. You have literally just described the Famicom disk system. That's exactly how it works. And maybe we'll play with that at some point. Because I did say it would be interesting to try and get Famicom disk... Take Famicom disk system floppy images, put them on an inappropriate floppy, and then still run them off the NES using an inappropriate set of ROM routines for supporting it. Now that would be something. Just totally, you're not even playing anything related, really, to the Famicom disk system, and yet it's a floppy. Anyway, this is my brain still not having ideas. Let's just do that. Usually I wait for a Wereworm or Trade MC to solve my problems for me. No pressure, guys. I'm just lucky to have that, and you have made me... What about... I have a learned... oh, why is this escaping me? I was just using this word the other day in a humorous context. Learned helplessness? Yes. I now have learned helplessness and cannot debug hardware issues or low-level software issues myself anymore. And it's your fault. Yeah, so in lieu of having any actual feedback, I am going to... That double seek seems awesome. That worked great. Oh, you know what I should have done? I mean, it would be crazy, but actually I am still going to do it. Is after it's done doing the initialization and trying to read some sector shit, Santiago says, we're sorry, not. Fine, I did this to myself, really. Took a weirdly longer amount of time this time. Anyway, no, I'm insane. Yeah. I'm insane. I was going to say check it after it's done all the floppy reading shit, but by the time we get to the monitor, it already is. Slow down, man. Okay. So, back to what I was thinking, which is literally, how's about we just try a silly thing and try switching to head 1, just in case. Question, did you verify the floppy drive's integrity before doing this? Would suck if you had a broken head, etc. while figuring this out. I feel... Oh, excuse me. I feel fairly confident about this. This isn't like a random floppy drive I have picked up. This is the floppy drive out of my Pentium machine, which has read many a floppy in relatively recent history. So it would be weird if it was just suddenly broken now. Not impossible, but it would be weird. All right, so just to, for shits and giggles, flip to the other head just to see. Because now I don't know that there's probably a status that I can read somewhere in a status register that would tell me if the last command actually blew up or not, but I'm not doing things the logical way. Oh, right. So it is head number shifted left 2, so that's going to be a 4. Head 1, drive 0. And this should be head 1. Sector 1. Cool. Yeah. Okay, all seems goodish. Let's try this again. Just for fun. I also realized that this is probably something I could just look up in the documentation of floppy drive layout, and floppy layout. That for some reason, like, it would be defined in LBA. Oh, here's Dave to also help my ailing, tired brain. Dave, we're getting different data now. So we weren't at track 0. We were off. We were probably at like track 3 or something after our reset and seek, because the recalibrate apparently only goes back 80 tracks, and it's sook in over 80 when the floppy initializes itself. So it was not sook all the way back to track 0. So subsequently, we were definitely reading from the wrong track, so the things weren't calibrated correctly. Who'da thunk it? So now we don't know if we're getting good. Well, we don't know if it's actually succeeding-ish, but we are definitely sook back to track 0 now. I turned it off. Why am I going here? And I know for everybody who's on this stream, I've re-explained this several times, but Dave he's my technical guru. And now we're trying to figure out, because we're at track 0 now. Seems to have resolved, it seems to have made things better, but now we're getting a different 7 bytes out of the first 7 bytes that we're reading from the FDC, and they still don't match what should be on the first sector of the floppy. I'm trying something insane and just switching to head 1, just in case. If the data changes, that's interesting, too, because that indicates that the data we're getting is off the floppy drive in some way, right? Theoretically. So, I don't know. But yeah, it was silly data. It was like 4 zeros and 2 2s. Okay, I think I did everything I need to do. And I already built it, I am sure. And I should probably pull this chip, because we're about to program it again. Ute, doot, doot. Programmer, load up the thing, do some stuff, and do some things, and some stuff, and some things, and stuff. It's not helping getting Queens of the Stone Age out of my head. It's really not. Okay. More fiddling. More fiddling. I have to assume Where Worm just left because he can't stand me just trying to, like, ad hoc my way through shit. Alright. Power's on. Other power's on. You gonna do something? Well, that's just fascinating. Let's just jiggle some things and do this and then try it again, just in case it's some kind of weird hardware. Fascinating. You'd think even if it failed, it would fail with some status crap. And now it's just hanging out. Neat. All right. Oh, what the heck? What? What the what? What? Okay. So it was just taking a really long time to execute the shit. That's spooky, but also very interesting. Let's go to 6, 8. Oh, that's the one. And our status is 06, which means we are at the track 0. And this is like the hearing my own voice. It's like the part in the movie where they say the title of the movie, and then you're like, oh, that's why the movie is called this. This is the moment. Like, this is the peak of why track 0 is called track 0, you know? As you get to this scene, you just keep talking about, we're definitely at track 0. Eventually, if you can beat on things enough, they either work or they don't. Spent a week getting audio to work on my Apple FPGA core, because I can't maths. Yep, that's all I do. Which I would like to reinforce. I have had people in the chat on this channel. I know a good number of people have said, you know, I watch you, but, like, this is impressive, or, like, you must be real smart, or, like, I don't understand half the stuff, which, I mean, that's a real thing if you just don't understand half the stuff. But you wouldn't, because you're not the one doing this. And it's because you aren't doing this. What I'm trying to say is, the beat on it until you get it to work thing is very real. I'm not anything special at this. If you plug some shit together like this and keep trying to get it to do something until it finally does it, you have done this. Yes, Dave says pure determination beats smarts every time. Anyway, I just want to do that to encourage people who are like, I'm not smart enough for this. I have like a brain made out of baked beans. Just FYI, it's garbage up here. And yet, here we are, accomplishing very important things. Anyway, let's look at those sexy bytes. 0207, doot doot doot. 80. Interesting. Very interesting, actually. 80 is supposed to be the fail byte, and it's not matching anything that the floppy would be giving back. So I think that was some kind of timeout situation, possibly, is what I'm feeling right now. 020. I bet these are all going to be 80s. Yes, they are. 0205. I screwed that up. 0205. 0204. Look at this. Completely unsurprised. 0203. Doot doot doot. 0202. Doot doot doot. 0201. Doot doot doot. 0201. Doot doot doot. So yes, it sent us nothing but 80s, and 80 is the shit went wrong code, or rather that when you read it, that means that it wasn't really expecting to send you anything, so it sends you an 80. Interesting. All I did was change the head on the read command. Well, error means it's doing something. I mean, it's the least useful error. It doesn't even say like there was an error with your command. It's just like it's like the floppy drive saying, "Why are you trying to read from the FIFO, dude? I have nothing for you." And the FIFO isn't even directly related to the floppy. The FIFO passes all kinds of data out of the floppy controller. So it saying I have no data is like, shit has failed hard. Like, things aren't even happening. So that's fun, till Daddy takes the T-Bird away. Like, is there anywhere else that I set up the head? No, right? Let's read some more shit. Read right. Yeah. Head number, shifted left 2. The drive number must match the currently selected drive. Well, it does, so there you go. Then the cylinder number, then the head number again. Just make sure I have those in the right order, which we did last time, so that's redundant, but okay. Command. Head and drive. Cylinder. Head. Yep, we're good. Okay. Here's the thing I want to try. Actually, really quick, that will tell us something. Is if I go back to reading from head 0, which is still weird because I should be able to read from head 1. Like, there's no reason I shouldn't be able to read from head 1. It's not the one I want, but I should be able to read from it. Anyway, so I'm going to switch back to head 0, and sorry, what I was going to do was up the number of bytes to be read after we start the floppy read command to 8, which this should just hang. We expect it to, because there are only 7 bytes available if it is a status result. So at the very least, if this hangs and then we know that it's probably a status result, then we can knock this back down to 7, stick it back in, run it, and read the status bits to see if they tell us anything interesting. You know what I mean? It's a poor way of doing things, but it's a plan at least. Back to get on track. Okay. Program. And go back home. Then we go over here, and we pull this out, and we stick it in, and then we fire up the stuff, and then we go, that didn't do quite what I expected. And then we scratch our heads for a bit. Wareham, who I am 100% certain is sitting there intensively reading the data sheet, says, maybe stash the read sector and try the read ID command. It would tell you the track. Ooh, that's interesting. Sure. Stash the red sector, yeah. The thing is, I can try that. I know I always have a but with your suggestions, but we still don't know if we can reliably read a whole sector. So we might still get a buffer overrun or underrun. But, whatever. Okay. I'm feeling goodish about this. Let's just leave this. Oh, nope. Fascinating. Let's make sure it actually read 8 bytes. If it didn't, then 0208 should be an FF, because that's what the nonsense memory values for this particular machine's RAM seems to be. So let's do 0208. Did I not? 0207. What? What? What is that? What? It's a 1 and... Oh, 1B? 1B. 1B? 1B. 1B? 1B. 1B? Okay, I'm just going to read this data just for fun, because now it's gone from disappointment to absolute confusion. Oh, good. 6. Let's just make sure 0207. Yeah, so there's a 1B in 0207. Is that just a shit value? 0205. 0204. 0203. 0202. 0201. 1B or not 1B? Trying to read single, double, or HD disks, and does controller set to supported modes for those. Theoretically, I have followed everything on OS Dev. Mind you, it's not the world's best written documentation, but I don't see anything. I have set all the settings that they say correspond to a high-density disk. Theoretically. So am I getting floppy data here? Is it... Because this still doesn't match my recollection. 1BFF? BFFEFF? And we can double check, but I think it starts E something. Let's double check. Just because. Because maybe it's reading good data. Or maybe it's reading some kind of horse shit. Wareham says, did you do the specify command, setting head settling timing and whatnot? Yes, I did. I sure did. Now, that doesn't mean I did it right. But you raise a vaguely good point in that maybe something weird is happening and it's reading garbage data. But it's weird because if these aren't like status bytes, if I actually am indeed reading 8 bytes out of here, which means it's not drive status stuff, then it's floppy data, and I would expect it to be somewhat consistent. Or then, I don't know. That would indicate to me that it read the head, or the cylinder number out of the sector, and it matched. Right? Because otherwise we would get that same failure in the same status bits. So if it was some weird, like, head deploy not being right thing, You'd think all the data would be fucked up, right? I mean, that would be my thought. I don't know if that's a cogent thought, but yeah, just FYI. Recalibrate. Version. Specify. Now, why specify is all the way up here, I can't remember. That's actually rather interesting. Because, you know what? I think it told me to do a specify command on reset, at least in the OS dev stuff, but you'd think that doing a reset would reset all the stuff you didn't specify, right? Let's just double check whether there was a reason that I did that. I mean, I don't think these are going to be horribly critical values either, but controller reset. A reset clears all the specify information, so the next select procedure must spend a new specify command. What? Am I just dumb? I bet I'm just dumb. Because I don't see anything in here that says I needed to send a specify before doing the reset. So, yeah, this is definitely a thing. Wait. Hold up. Let's reread through what I do really quick. So, we toggle the physical reset signal. Then we toggle the hardware reset, or the software reset signal. Then we send for or sent in commands. Then we send a configure command, which, you know, could be issues there too. We set the data rate. We use the specify command here. Then we send a version command for no good reason. Oh, okay. So no, I was just reading that wrong. We do the specify command after reset, and we do it like right before the seek. So, or right before the recalibrate. So I think that's fine. Let's check drive selection. So send the correct data rate setting to the CCR. Usually this is a 0 for a 1.44 meg floppy drive, which we do right here. That's the whole thing here. Then if it's different type, or changing from PIO to DMA, send a new specify command. Regardless, we do send a specify command here. And then we set the drive select bits in the DOR, including possibly turning on the drive. Now, here's a thing. Oh yeah, no, we do that right here. Right there. So, that seems fine. That seems just fine. Let's double check this specify command stuff, because, yeah, all of the setup stuff we should be a bit suspect about. Specify is 03, and, okay. We stole our values from this. These parameters sent with specify command to the controller are meant to optimize drive performance and head lifetime. They're specific to the actual floppy drive in there. They're supposed to be double checking shit all the time. You don't need to do it. It's not very useful. But what we set it to was the shit in here. So for a 1.44 megabyte floppy and 8 milliseconds delay time, that would be an SRT of 8, which I believe we set. Head load time. Wareroom says, the comment says you set 500k bit, but you told me yesterday it is an HD floppy. I am in confusion. Please explain. Okay, so here's the thing. Right, here's the thing. Do you feel similarly that that is super incorrect? I mean, I'm reading a data rate of 500 kbps multiple places here for them saying a 1.44 meg floppy. But in the data sheet, I recall seeing that that is for a double density floppy. Am I crazy? Am I totally crazy? I don't know how to... Yeah, let's double check in here. What are we looking for? Data rate select. Okay, so MFM, 1 Mbps, and 1 pp per second, and 500k per second. And does it tell us, where was I seeing this? Data rate 0 through 1. Select one of the 4 data rates. The default value is 250. Whatever, and then... Is that seriously all you're going to tell me about that? Okay. Oh, here's the stuff we were kind of looking at the other day. That's interesting. So if your FIFO threshold is 8, you have 126.5 microseconds to read those 8 bytes before you overflow at 500k. Half that for 1 meg. So that's interesting to know. But moving on, where does it say what to do? Oh, interesting. Wait. The digital input register says some shit. High density is low whenever the 500 kilobytes or 1 megabyte per second data rates are selected. This bit is independent of the effects of the ident and invert pins. That's cool. I wonder if that's a thing. Wait, what does the Dencel pin do? Because I wonder if that is relevant. Unless that's just for startup. What are they telling us? Following is changed in PS2 mode. Bit 6, 5, 4, and 3 return a value of 1, and the data rate select 1, 0. 1 through 0 return the value of the current data rate selected. See table 2.4, high density, the thing I just read. I'm curious. Let me check something really quick, because I feel like this may be a thing related to me setting the density select pin. Unless density select is a signal that comes in from that floppy drive, which it probably is, the more I think about it. Dencel. Okay, so we've got data rate output on here. Dencel. Oh, here we go. Density select, which is an output. So this is an output that indicates what the density selection is. Okay. Damn. I got excited about that for a second. Just double checking if there's anything interesting that I may have wired up wrong. Doesn't look like it. Yes, Santiago says, oh man, I did my data archaeology on floppies like a year ago. I forgot all of this. Tell me about it. I am in the exact same boat. I'm leaning towards let's look at some code again. And, or, like I said, I swear it said something of the nature of, here's the settings you should use for double density. 500 kbps is for double density floppies. That's what it is. I mean, I could probably do some research elsewhere, huh? tell me the answer. Because you may be a lover, but you ain't no dancer. I'm spinning. Worm says 500 kbps might be right for HD. Damn it. Yeah, because if the PS2 floppy controller supports 2.88 floppies, then I would assume that 1 meg is for 2.88, right? Right. I don't know, man. I just don't know, man. You know what I still haven't done? I still haven't looked at this floppy hex dump. Let's do that. This is a piss poor episode, let me tell you what. To the start of this thing. Yeah, that's what I thought. EB28. For fun. Okay, and yeah, Dave says 250 is DD, 500 is HD. Good to know. But yeah, so about right. I was going to check. Is there a location that goes 1BFFBFFE? 1BFFBF. Sorry, I'm looking at OBS to see the NES output, so I'm just going to search this, and you won't be able to see. Sorry. 1BFFBF. Nope, not found. So this is not floppy data, or at least not data that would correspond to a proper image of this disk. There's the question of, is this disk okay? You know? Ooh, let me check something real quick. Is there a flag for checking overflow? DOR stuff. In execution phase, command busy, drive seeking. CCR and DSR. The bottom two bits of DSR match CCR, and setting one sets the other. Cool. Good for you. dir register. I'm not seeing any obvious registers that tell me when an overflow happened. Let's look for overflow. Loop back to the beginning of the outer loop unless your data buffer ran out. Detect underflow, overflow. How do I detect underflow, overflow? Because that's what I'd like to do right now. Is I should be having an overflow situation. Ideally. Yes, but what we were going to do read ID. Was that what we wanted to do? Let's try doing a read ID. Let's go back to this, because Wereworm said let's try read ID. And I'm going to try doing a read ID, because, buddy, I'm lost. Read ID, read ID, read ID, read ID. Probably not in there. Oh, goodness. Read ID, read ID, read ID, read ID. Cool. That's telling me what Wereworm was saying about making sure you're in the actual right location. Read ID. Read ID. It's used to find the present position of the recording heads. Stores the value of the first ID field it is able to read into its registers. If the thingy does not find an ID address mark on the diskette after the second occurrence, then it sets the IC code in status register 0 to a 1. Blah, blah, blah. control commands to be followed by sense interrupt. Cool. Very good. So I guess let's do that. Read ID. Read ID. What is your format, please? Read ID. Read ID. So it's going to be 4A. 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 And then it returns me all the things. Sounds good to me. So actually, I am going to skip the whole friggin' read command. Skip it, skip it, skip it, skip it all up. Skip it, skip it, skip it. That's what I want to do. Okay, right here. Jump. Init. Test remove. And let's steal this wait for IRQ sense interrupt thing, because we're going to need to do that. And sense read ID, just to make sure we're not going totally insane. So that was load A 08 and 08. Where am I getting that from? Out of my ass is where I'm getting that. That was 4A. 4A. JSR, send FTC command. Doodly doodly. And then the, let's see, so that will be also 0. Load A. Zeros. Send FTC command. And then we just wait for the data to just flow on in. And actually, you know what we can totally do is skip over this command, replace this with a 7, skip, read command, yeah, and then we'll just read our 7 bytes there, because we're tricky. We do need these buffer addresses to be set up, however, so we will do the jump here, jump, skip, read command, and remove this. Okay, so basically, instead of doing a read command, we will actually be doing a the thing that is really easy that I can't remember, read ID. We'll be doing a read ID instead. And I'm curious to see what it says, but I also feel like it's probably going to tell me exactly what I expect, which is it's on track 0, head 0. But, you know, at least then we know that it's doing stuff, which we already kind of knew. It's just not doing the stuff we want it to do. Ya bastard. Give me the chips. Give me the chips. Load stuff. Here we go. Okay. Program. Okay. I'm back. The annoying thing is, if I am led to the inevitable conclusion that the thing is actually reading the disk just fine and the data on it is hosed, which would also be fine, but that's probably the next thing we should verify, because it's all about verification and making sure we're checking our assumptions, because it would be really funny if it was working a couple of tries ago. Yeah, where said if it checks out, next I would verify that floppy is still readable by the PC. You came up with that at the exact same time that I did, so I think it is obviously logical time to do this. But let's see what we get. Let's see if it's weird. I don't anticipate. Dump the shit. 0207 doot doot doot. 0206 doot doot doot. 0205 doot doot doot. 0204 doot doot doot. 0203 doot doot doot. 0202 doot doot doot. 0201 doot doot doot. Wow, what the hell is going on? Something's hosed, brothers. Something's super freaking hosed here. I am at such a freaking loss. This is obviously not right. Yeah, 80 equals illegal command, which I was talking about earlier. So that's why I'm saying this is real screwy. Let's double check my code. Sleepy brain is sleepy brain, and I may have done something very stupid. Read ID. Let's make sure the command is actually 4A. That would be embarrassing if it wasn't. I read that right? Read ID. So it's 0. And then the MFM bit, which should be high. 0, 0. That's a 4, yeah? 1, 2, 4, yeah. And then 8, 9A. 4A. Okay. You fucking moron. So actually, in what order are you supposed to do these? I'm saying you fucking moron because you know what's screwing it up is this sense interrupt command. But that raises the question of, are you supposed to do a sense interrupt after you get the data back? I don't know. Let's assume that's true. Actually, I'm going to delete all of these because we shouldn't even really have to wait for the IRQ because the RQM bit is going to tell us if it has something to send us. So, yeah. Let's kill that part. Because that is probably why we're getting Garbo there, is that the sense interrupt command is sending us data for the sense interrupt command. Crazily enough. Oh, build it. Oh, UD-do. Oh, program it. Oh, blue, blue, blue. Set this to 1. Okay, I'm done. Program it with the programming thing. Murray Smith says, disconnect the drive from the controller and check if the controller sends back sane data for resets, seek, etc. via status register. What would that tell us? I'm not sure what that would tell us. So, please expand on that thought if you actually have like a good working theory here, because I'm not following. Hold up. My chip's not even in. Hold right the F up. Oh 0207 doot doot doot. 0206 doot doot doot. 0205 doot doot doot. 0204 doot doot doot. 0203 doot doot doot. 0202 doot doot doot. 0201 doot doot doot. Even weirder garbage. What the fuck? I'm surely doing something wrong here. Surely. But I'm already over an hour. You know what I'm gonna say? I'm so sorry, you guys. I'm going to call this one a loss. Oh, we're obviously still gonna need to do some poking at it. You know what? Before we just call this a loss, one thing we can definitely do that's not gonna super help us. Seriously, what the hell is happening there? I'm sure it's my jumping all over the place code is just messing shit up. But yeah. Let's go read this floppy. See what is actually physically on this floppy according to another compooper. And then we will call it a day. Because it would be very nice if, we read it and it like started with a 1B. So let me move over real quick to a computer that actually has, excuse me, a floppy drive. Moving a mic, singing the song. This is the only melody I know. Hi. Nausea camera time. You know what? We're just gonna leave it on the desktop for a minute. I have a tripod this time, so that's fun. Where was that? Do you send 2 bytes for read ID? I sure do. I sent the command and the head and head and disk select numbers. It's probably my code just being shit, but I feel like I am in no place to mess with it right now. Sorry, I know that's a bit disappointing. Okay, let's see about this tripod. Look at my belly. It's full of meatballs. Look at that, and you don't even have to look over a suitcase. Very advanced. Where is my floppy? It is here, right here. Let's stick it in this drive over here. Then we will type in a super secret admin password that I often forget. But not today, boy. Anyway, sorry in advance that this episode was a bit of a bummer. They can't all be winners, particularly when you stream live every single weeknight. It's just not possible. Where am I going? I need to go to raw right. With that exposure, you can't see shit. Not that, it's not like it's critical that you be able to see anything, but I figure it's probably more entertaining if you can. Raw right, raw right. Read to supposedly disk1.img. There we go. Come on, buddy. Read some shit. Come on, and it can do some stuff. Thanks. My coworker Tom says, ooh, CRC error. That's fun. Maybe this disc is totally hosed. Can you play the original Lion King game on that? On what? On this computer? Probably. Was the original Lion King game a DOS game? I can't remember. Huh. This would be really funny. You know, you guys want to try something? That Tom would be coming in just in time for. Let me grab another floppy. Of course, it may be that this drive is a piece of crap too. Sorry for the epilepsy. Seriously. That is terrible for people who even don't have epilepsy. I'm going to try one of these Sony HD discs. And we will actually write and verify this disc a couple times first. Let's first disc one. Write it up. Tom, get out of here. Don't actually get out of here. It's fine to have you here. Wow, this is terrible. This is the worst thing that I've ever seen. 1 second. Nausea mode. It seems to do better or worse based on angle that it's looking at the screen. That seems better. Where was it going? Oh, Tom, it's a rave. Try to name a folder con and explain why. That's why I was saying get out of here, Tom. Murray says dirty heads on the FTC. That's a real possibility. I mean, this is an old shitty drive. Says successful, but let's actually try reading it now. And see if we get a cool CRC error. Because it would be cool if our data was just, fuck. And then we go back and we try just reading the sector again, and it totally works just fine. That would be really neat. Let me get Sigwin ready for this. And I guess I don't have to verify this multiple times if I read it and it comes up okay. All right, let's try and remember this OD crap. So, CD, SIG drive, C, documents and settings, administrator. My documents, raw right? No. Microsoft DOS 331, 3.5 inch. Yes. Yes, very good. So let me, now that that is read, it read successfully, right? That's what it says. At least we didn't get a CRC this time, and a CRC error. Okay, so let's try, what was that? Cat, supposedly disk1.image, od-tx1? Does this have history? Does this have console history? There we go. It was TX1. I was right the whole time. Damn you. Supposedly disk1.img. And dump it into more. Command not found. Fascinating. To the hex we go. Supposedly disk1image dot hex. Vi supposedly disk1 dot hex. EB28. That was right? Vi disk1 no. Disk1.hex EB28. Again, EB28. Wouldn't it be hilarious if we just had a bad floppy? Wouldn't that be so funny? Well, anyway, this one's verified. This one is verified. Verifado. Ooh, spicy. Wereworm says, Tom, actually you can name a file con. I'm only vaguely aware of the whole DOS special file name thing, so sorry, Tom. You come into my chat, and you get the hyper nerds. We're gonna show you up. So good on you for even coming here, knowing that there are some insane hyper nerds. But But thanks for the fun fact, Werewolf. Not enough NES. I'm out of here. Try not to stay up till 4 a.m. this time. That's not why I stayed up till 4 a.m. I was actually doing work for my job at 4 a.m. Yes, I have poor time management, but still. It wasn't this. Okay. Now I have to revert a bunch of my code. Because I'm excited about this. I shouldn't get too excited. And you know when I get excited is when it doesn't work. But, oh boy. So we want to kill everything about read ID. We want to... I mean, is that more or less it? Oh, wait, no. We want to not skip the read command. How about I just, you know, the whole reason I put those test remove things in here is, you know, so that I don't, so that I can remove them later. So maybe check that real quick. Test. Oh, right. We actually don't want to test remove this. This is the second recalibrate, and it's super important. Okay, I think that's it. Tonic says, Hyper nerds have nothing on me. I can handle you. I can handle them. That is totally fair. Also, Wereworm is very nice. Wereworm would not be a mean person. Okay, I think that's it. Hopefully there's nothing else that I'm forgetting that I moved around and messed up. Like I didn't... The head is back to head 1, right? Or head 0, yes. I think that was it. Hopefully. Seek still looks right. I don't think I changed anything about recalibrate, except for the fact that I'm doing 2 of them now. That's not a PowerShell command. I feel good. I feel goodish that at least the code is where it should be. Bated breath, y'all. The code. She is going on to the chip, whether you like it or not. And plop. And either way, I'm done after this. Just be aware. Power. I mean, it would also be funny if that CRC is because of the things that I've been trying to do to that floppy. Yeah. A real long wait, which I don't like, but it does give me the prompt. So, yeah. Oh, you know what might be taking all the time is the second recalibrate, because that first recalibrate takes a little bit, and then it would seem to be doing nothing, but that's because it's probably trying to go back another 80 tracks. I need to get out of here. Let's do the regular old dump and see what we see. 0208. We dumped 8, right? Let me check. Let me check. Oh, I was also supposed to mention that, for no good particular reason, Dave was so adamant about making sure that I knew that the bytes would be written into memory backwards and from an offset of 1 from the address that I was looking at, that he was texting me in the middle of the stream to try and get me to look at his damn messages. Which would have been useful at the time, but didn't set me behind terribly. Anyway, right, sorry, just checking my loop for how many loops I was doing. Yes, I am doing 8. Just wanted to make sure. 0208, doot doot doot. 0207, doot doot doot. 0206, doot doot doot. 0205, doot doot doot. 0204, doot doot doot. 0203, doot doot doot. 0202, doot doot doot. 0201, doot doot doot. And it's zeros. Well, that's the end of this episode, folks. I am truly sorry. I mean, one step a day, and again. when you do a stream every single flippin' day, what do you expect? You're gonna have some duds, especially when you start hitting the difficult floppy controller software part. But I'm annoyed by this because before I was at least getting some data, and now I'm getting zeros all day. Santiago says getting closer. I do feel like we've gotten a little closer in that, yeah. Clearly we're reading 8 bytes of something. And Wereworm got us on the right foot, and I really appreciate that. With the double reset thing. Not reset, recalibrate, double recalibrate, which seems to have improved things. And yes, we don't get an error status anymore, which is V good. But the data seems to be all fucky, so... You know, I wonder... Next thing we might want to try is reading a limited number of bytes. Because I wonder if the FIFO gets weird when you let it overflow. I do wonder this. I would kind of expect that it would just fill up all 16 slots of the FIFO and then just, you know, at that point it would trigger the error and fail the command. But I mean, I am definitely going to be overflowing here because I'm reading no more than 8 bytes. So maybe that's what's up, is that the FIFO just gets garbled up on an overflow or underflow. Who's to say? You guys want to try something really dumb? Just on that note? Really dumb. Really dumb. But, you know, 3 minutes left before we're at an hour and a half, so. Dumb is the name of the game right now. What if we remove this, and doodly 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 doo. What do I need to do here? I need to change these back to inline and set this to 0. And let's just, the fun thing is it's totally possible that we're still too slow, regardless, but you want to try just reading them all before we get out of here? I mean, why not? Why not? At the worst, nothing friggin' happens. And that would be fine too. It would not be any more disappointing than what I am experiencing right now. Build it. Program it. I don't know why it makes me feel uneasy when this window closes very quickly. It does that every time. You're fine. Program it. I would love to know how many cycles we've done on this chip so far. I was going to say somebody who is watching very intently could go back through all of the episodes and count, but I'm pretty sure this chip was used for shit before I started this project. Yes. I'm always paranoid about not actually having written the code to this properly, but it has yet to have actually been a problem, so. Paranoid guy is paranoid. Here we go. This may just hang forever. Ooh. 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 It's still, I guarantee you, it's still gonna be garbage. And now we read in the proper order. 0200, you do. Interesting. 0201, you do. Oh, it's the garbage we were getting before for the sense command. Just random 80s and Fs. 0202, you do. 0203, you do. 0204, you do. 0205, you do. Yep. Okay. next time. Rapidly out of here. See you, love you, bye.